So this is the master problem. This is something which you could potentially see on a test or a midterm. And the reason they do this is things aren't clearly defined in the XY axis, and you're given this angle here. So they want to test and see, do you know how to use the equations with trigonometry? And the reason they give you a 30-degree angle is because they're not cruel individuals. They're actually trying to make this easier. So sine of 30 degrees is 1/2, cosine 30 degrees is root 3 over 2, sine 60 is root 3 over 2, and cosine of 60 is 1/2. So when they do give you this, and you can almost guarantee this will show up in an assignment or a midterm somewhere, there is a trick. You say, well, I'm going to change the axis. And I'm going to say this is my x direction and this is my y direction. So making this the x-axis and this the y-axis. And you can do that. That's totally legitimate. And usually they'll ask like, what is the acceleration along this line? So they actually expect you to do this. So when we change the xy axis, you don't have to redraw, but I like to. So this is now our new situation. It just makes things easier. Still a 90-degree angle. And the y-axis. So this makes life a lot easier now. So the free body diagram for this represents the sledder here having a fun time going down this hill by its center of mass. And we know that the normal force is always perpendicular to the surface. So it will be pointing perpendicular 90 degrees to the surface along the y-axis. And we know that there's an acceleration going along the x-axis to the right. And we know that there is, because this ladder is moving, there is kinetic force of kinetic, because it's moving, friction, counteracting its movement. And then now mg, remember mg was coming down like this, force of gravity. But now, with our new axis, it'll be coming down like this. So this is our new force of gravity. Then our new axis we've set up here means it will be coming down something like this. So that's the force of gravity. Okay, so now we just do the exact same thing as the previous examples. We figure out the sum of the forces in the x direction along the x-axis. So we have a component of the force of gravity. It's going to be acting, so this component here, force of gravity in the x direction. So we'll represent that as force of gravity along the x direction. Positive, because it's going to the right, and negative, the force, I really need new pencils, force of kinetic friction, and it's negative because it's pointing left along the x-axis. And now, in this case, it's not equal to 0 because we do have movement and acceleration, so this is equal to ma. And acceleration is a vector, it has a direction, and our acceleration is positive because it's going to the right. So, now we look at the sum of the forces in the y direction. And we have, well, the normal force is positive. It's pointing upward. And we have the components of gravity going down. So Fg along the y-axis. So we have negative, because it's going down, the force of gravity in the y-axis. So negative force, gravity, y-axis. And this, so notice how acceleration is only on the x-axis, so this is actually equal to 0 because there is no acceleration on this xy axis we've set up, It would be different if you were still working in this. These would both have accelerations, but because the y direction, there is no acceleration there, it is just equal to 0 now. So we've really simplified this problem. So now we need to solve for force of gravity in the x direction, force of gravity in the y direction. They give us the force of kinetic friction, and we can solve for the normal force once we get force of gravity in the y direction. And we want to, of course, find the acceleration. So to work out the force of gravity in the x direction, we're going to go back to trigonometry. So this triangle needs to add up to 180 degrees. So we have 30 degrees, 90 degrees, means this angle has to be 60 degrees here. So say we want to find the force of gravity along the x-axis. We know SOHCAHTOA, so TOA, sine of the theta equals opposite over hypotenuse, but in this case we want the adjacent, so we're going to use cosine. So we know that the force of gravity, the x direction, is equal to, well, I'll just run through the math quickly. So cos theta equals, we've labeled this adjacent side force of gravity, the x-axis, and then we have our hypotenuse, which is just the vector, the force of gravity. So multiply both sides by Fg. So force of gravity in the x direction is going to have force of gravity, the hypotenuse, times cosine of 60 degrees. And remember, cosine of 60 degrees is 1/2. So they've made it a lot easier. So 1/2 minus force of, so we're done there. So now we can represent force of gravity in the x direction. We can say it is now the force of gravity times 1/2 equals force of kinetic friction, or minus force of kinetic friction. And we do have the mass, so we can actually solve for the acceleration now. So along the x-axis, we want to divide both sides of this equation by mass. So acceleration equals force 1/2 force of gravity minus force of kinetic friction divided by mass. And this is equal to, well, the force of gravity is mg. So we know equals mg. So we know the mass, 10 kilograms, and we know g is 9.8 meters per second squared, so it's equal to 98 newtons. And so 98, 1/2 of 98 is 49 newtons, minus, we know kinetic friction is 9 newtons, and we know the mass is 10 kilograms. So 10 kilograms. So the acceleration is 49 minus 9 divided by 10, so 4 meters per second squared. Okay, and now we just want to figure out force of gravity in the y direction using the same Pythagoras theorem as SOHCAHTOA to get the normal force. So in the y direction now, down here, well, this angle is 60 degrees. We know that this angle here is 30, and that this is 90 degrees. This angle here is 60 degrees. So we're looking in the y direction now, and we want the adjacent again, so we can do the cosine of 30 degrees. So in the y direction, the force of gravity in the y direction is equal to force of gravity, so the hypotenuse, times the cosine of 30 degrees. And cosine of 30 degrees is root 3 over 2. So this is equal to root 3 over 2 times the hypotenuse, which is the force of gravity. So on the y-axis now, we know what FGY is. So I'll just work over here now. So Force in the y direction is normal minus, well, FGY is the same as the hypotenuse times cosine of 30 degrees, which is root 3 over 2. So normal force equals force of gravity, which is 98 newtons, times root 3 over 2, 8 newtons, which equals 49 root 3 newtons.